Yes. From nuclei chapter, let us discuss the another long answer. What is radioactivity? State the law of radioactivity decay. Show that radioactive decay is exponential in nature. So first we have to define what is radioactivity. Okay. So radioactivity means if we take heavy elements after atomic number 82 from 83, bismuth, uranium, polonium, etc., 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 their nucleus will undergo decay or disintegration by emitting alpha, beta, gamma radiations. So it happens spontaneously only, by itself only. It loses alpha, beta, gamma radiations. For example, uranium 92, no? Okay. For example, uranium 92. If by any process, if it loses, for example, alpha particle. What is alpha particle? Helium, doubly ionized helium, we call it as alpha particle. Now what happens? 92 minus 2 means 90. What is 90? Thorium. So uranium has decayed to thorium, or uranium has converted into new nucleus thorium by emission of alpha particle. So it happens spontaneously. Such spontaneous disintegration, if you feel harder to remember disintegration, use decay. The spontaneous decay of heavy elements by emission of alpha, beta, gamma radiations, we call it as radioactivity, right? So the process of spontaneous decay of nuclei of heavy elements with emission of alpha, beta, gamma radiations is called as radioactivity. Next, what he is asking? He is asking to state the law of radioactive decay. He is asking to state the law of radioactive decay. So before that, let us see. For example, assume that in a sample, 100 uranium atoms are present. Okay. In a sample, we are having 100 uranium atoms. Okay. Now, due to emission of some radiation such as alpha or beta, let us assume that from 100, 20 atoms are decayed. Okay. Now, how many remained out of 100? 80 remained. So, what is radioactive law is saying means, this rate of decay of, or rate of decay is directly proportional to atoms remained at that moment. Remained at that moment. How many are remained? Out of 100, 80 are remained. 80 atoms are remained at that instant. So that is radioactive law. So the rate of decay or disintegration, we write as dN by dt, is directly proportional to the number of atoms present at that moment. The atoms present at that moment we are indicating with capital N. This is known as decay law. Okay, this we call it as decay law. Now what is the third part of the question? Show that radioactive decay is exponential in nature. Right? For that, first I said 100 atoms here, no? We are denoting that with a naught. Now, number of atoms left, that is 80, I am saying, no? That I am denoting with a capital N. Now, 20 atoms disintegrated, I said, no? That we are denoting with a Dn. Right? So, let number of atoms present in radioactive sample be N naught. Number of atoms left at time t. This is at time t equal to 0. As time increases, the disintegration has started. And how many remained at time t? N has remained. Now, number of how many atoms disintegrated? Number of atoms disintegrated in time dt is dn. Now, as per definition, what we are saying, the rate of disintegration is directly proportional to the number of atoms present at that moment. That is dn by dt proportional to n. I am writing negative here. Here, negative sign indicates that number of atoms present, number of atoms present in sample decreases with time. That only happens, no? From 100 it has decreased to 80. From 80 it decreases to 40 in such a way. So, if we take time on x-axis and number of atoms remained on y-axis, in such a way they decrease. Okay, this the negative sign indicates. Now, I am writing this as dn by dt. I am sending minus, I am writing this side minus lambda n. Right? Here, lambda we call disintegration constant. We call it as disintegration constant or decay constant. Your wish. Just rearranging these terms. How means? This n I am bringing under dn. And dt I am taking to this side. Lambda dt. Now let us integrate this. Now, okay, let us integrate this. What we will get? Integral dn by n is equal to lambda is constant, no? So I am writing outside dt. Now what will be the limits? Okay, what will be the limits? How many atoms are at t equal to 0? N naught. And at t equal to t, how many remained? N. So limit is n naught to n. And time we started from 0 to t. So time limits 0 to t. Now integration of 1 by n dn will be, remember the formula, log e n. N naught to n. Integration of dt is t. 0 to t. Next, what we will do? First, we will substitute upper limit. In place of n, what is the upper limit? N. Then put minus sign. Then substitute lower limit. Same, log e in place of n, lower limit, n naught. Similarly, this side also. First, upper limit, t. Put minus, then substitute lower limit in place of t. What you will get? 0. Now what you will get? Log e n, very simple mathematics. Minus lambda t minus 0 t. Right? Now in mathematics we are having a formula, log a minus log b equal to log a by b. Let us use this formula here. In exam, no need of writing this, just for you. Your knowledge, I am saying, that's it. Okay. So log E n by n naught is equal to minus lambda t. Now next, n by n naught, it becomes e to the power of minus lambda t. Okay, removing logarithm. N by n naught equal to e to the power of minus lambda t. Now send this n naught to this side. N equal to n naught e to the power of minus lambda t. What he said? He said to show the radioactive decay is exponential in nature. E to the power of minus lambda t, we proved. It is exponential in nature. So this is about law of radioactivity. Okay. So by this we completed LAQs. So what are the important LAQs? From waves chapter, formation of waves, stationary waves in stretched strings. Formation of stationary waves in open pipe. Okay. Formation of stationary waves in closed pipe. Next, Doppler effect. So I'm not saying compulsory this will come. Just these are the important questions which are continuously repeated in all old papers. In some of the old papers, we will find beats Doppler shift question also. Okay. Now next, from current electricity, potentiometer, two questions will be there. Comparison of EMFs of two cells and finding the internal resistance. And next, Kirchhoff laws and finding the principle of Wheatstone bridge using Kirchhoff laws. And from nuclei, the important questions are nuclear reactor or generator and radioactive law. Even we are having stellar energy and mass defect also. In some question papers, even they asked stellar energy mass defect also. So these are only important questions. So focus more on these important questions. If you like my video, share it, subscribe it. Yours, Reshma Physics. Thank you.